In this video, we will learn how to prove whether a production function is concave or convex. This question was asked in Indian Economic Service paper of 2024. The question goes like this: show that the production function Q is equal to log of L raised power beta 1 times K raised power beta 2 is concave for all beta 1, beta 2 greater than 0. Okay, so we need to prove it is a concave production function. First thing, what will we do? We write the given production function, or we simplify it. So can I write Q is equal to log L raised power beta 1 plus log K raised power beta 2? Obviously I can, because we know that from the law of the logarithms, log m times n is equal to log m plus log n. You know it pretty well. Can I further simplify it like this? Q is equal to beta 1, I will make it coefficient log L plus beta 2, again it becomes coefficient, we get log K. How do I write it? Again it comes from the law of logarithm. Okay, that is, if we have log x raised power n, it can be written as n times log x. Okay, so don't need to worry. Okay, sorry for my English, Kosher English, obviously. Now I have simplified a little bit the given production function. Now what I need to prove here? I need to prove that the given production function is concave. To prove it is concave, I need to prove it the given production function is negative semi-definite. Okay, remember this. So to prove that the given production function is concave, I need to prove that it is negative semi-definite. Not this production function, but the matrix that I will be constructing. Okay, so first thing is, what I need to do to prove it whether it is concave or convex, I need to form a Hessian matrix. Okay, you know, I don't know whether you know or not, I have made n number of videos on the Hessian matrix. So what is Hessian matrix? Hessian matrix is a matrix which is composed of the second order partial derivatives of the production function with second order direct partials on the principal diagonal and second order cross partials on non-principal diagonal. And let me write it here. So H will be a matrix which will be formed by the second order derivatives, that is QLL. That means the second order derivative of this, the second order partial of this production function with respect to L. Then we have QKK here, that means this is called the principal diagonal. Then we have QLK and QKL. I need to construct this kind of matrix. Okay, now let us find out QL. What is QL? Means the partial derivative of this. To find out Q subscript LL, first I need to find out the first derivative of the given production function with respect to L. Okay, so derivative of can I write it like this? Derivative of log L is 1 upon L. So we have beta 1. Derivative of log L is 1 upon L. Since no L is involved in the second term, its derivative is 0. So this is first derivative. Okay, now QLL means the second derivative of the first derivative. Again differentiating this partially with respect to L, I will get minus beta 1 upon L square. If you are getting confused, let me explain it. How did I get this negative term here? So since this is the first derivative, can I write QL again like this? Beta 1 times L raised power minus 1. QLL means, using power function rule, this minus 1 becomes coefficient. Then we have beta 1, L raised power and exponent is subtracted by 1. So we will get minus 1 times beta 1 is minus beta 1. L raised power minus 2, that is minus beta 1 divided by L square. Okay, that is how did I get QLL. Now I need to find out okay, QLL. I also need to find out QK first. Okay, QK will be equal to the partial derivative of this production function with respect to K this time. Okay, so let me cut it short. So I will get beta 2 times 1 upon K. By the same logic, QKK will be equal to minus beta 2 upon K square. Okay, also I need to find out QLK. So QLK means the derivative of this, since this is QL, the derivative of this function with respect to K, since its derivative will be equal to 0 here. Okay, because no K is here. Also we need to find out QKL. That means the derivative of this function with respect to L. No L is involved, its derivative is again 0. So what will be our Hessian matrix? So H will be equal to QLL. Nar lugayat shamat gona ay he tapoid go yet for it. Okay, so what is our QLL? QLL, it is minus beta 1 divided by L square. QLK is 0 and QKL is again 0 and QKK is minus beta 2 upon K square. Kartani ban Varishini Rossi. Now let me rub this out. Now to to prove the given production function is concave, I need to prove that H is negative semi-definite. Okay. Here you can also see this H is a what we can say that H is a symmetric matrix. Okay, by symmetric matrix, what I mean, a square matrix that is equal to its transpose is called a symmetric matrix. Okay, so to prove that H is negative definite, we can say that H is negative semi-definite only if and only if, let me first explain what is meant by symmetric matrix. Okay, so a symmetric matrix is a matrix which is equal to its transpose. That is, if I have a matrix A is equal to 1 0 0 1, let us say, if I take its transpose, again transpose meaning interchanging rows with columns. So this is row, let's make it column, this is row, let's make it column. So again this is equal to this matrix. Okay, so when the transpose of a matrix is equal to the given matrix, it is called a symmetric matrix. Okay, now I need to prove that H is what I call shamat gana. I have to prove it is concave. So I say H is concave only if it is negative semi-definite, and we say a matrix, a symmetric matrix H, let me write it here, a symmetric matrix in this case H is said to be concave. Okay, if and only if every principal diagonal element, if every principal minor if every principal minor is what I can say non, okay, so if every principal minor is non positive or negative, okay, it is non-positive, we say a symmetric matrix H is said to be concave if every odd principal minor is non-positive and, okay, every even principal minor is non-negative. Okay, don't get confused. By non-positive we mean less or equal to 0. By non-negative we mean greater or equal to 0. Okay, so what is meant by the principal minor of the given matrix? Let me explain that very thing also in this case, and I will explain that. H1 will be equal to the determinant of this matrix, that is minus beta 1 divided by L square. This is our H1. Okay, only this matrix. Its determinant will be obviously if we have H is equal to 2. Its determinant is also 2. Okay, what is H2? H2 is this whole matrix. H2 will be equal to minus beta 1 divided by L square. We have 0, or let me write it here. Then we have 0, here we have 0, minus beta 2 divided by k square. Okay, now determinant of H2 means the determinant of H, if it is what I am trying to prove here. I am saying that a symmetric matrix H is said to be concave if every odd principal minor. So this is the odd principal minor, then we have the even principal minor. Okay, so I only have two principal minors here, obviously. For the obvious reason, I have 2 by 2 matrix here. So if every odd principal minor is less or equal to 0, we say not only this, that every odd principal minor should be non-positive, that is less or equal to 0, but every even principal minor should be non-negative, that is greater or equal to 0. Now let us see if these conditions are fulfilled in this case. Here you can see H1 means this minus beta 1 divided by L square, only one element here. Since beta and beta 2 are greater than 0, okay, that means this term will be less or equal to 0. Okay, so here we can see that odd principal minor is non-positive, that is less or equal to 0. Let us find out the even principal minor, that is H2. So H2 will be equal to, so since H2 is this, it's let's take it as a determinant. So multiplying these two elements, we have minus beta 1 divided by L square times minus beta 2 divided by k square. Multiplying these two, then subtract and multiplying these two elements. You know how to take determinant, that is 0 into 0. Here you can see it comes out to be, it is equal to, if I write it here, H2 is equal to, so minus into minus is plus, we get beta 1 beta 2 divided by L square k square. Okay, so H2 comes out to be greater or equal to 0, or it is obviously greater than 0 in this case. So we can say that the given production function is concave because the symmetric matrix, which was formed by taking the second order partials of the given production function, okay, with the second order direct partials on the principal diagonal element, on the principal diagonal, and the second order cross partials on non-principal diagonal. Okay, then when we took the minors, that is the minors of that very matrix, and if every odd principal minor came out to be non-positive, and even principal minor came out to be non-negative, we say that the given production function is what I can say concave. Okay, so if you are getting confused here, let me explain how do we take the let us take any matrix, not specifically symmetric. So let us say it is A, B, C, D, E, F, G, H, I. Okay, I am trying to show you the principal minors. Okay, so first H1 will be this matrix A. Okay, then H2 will be this very matrix, that is A, B, D, E. Then H3 will be this whole matrix, that is A, B, C, D, E, F, G, H, I. Okay, now we say a matrix is said to be a negative semi-definite if every odd principal minor, that is this is the odd, this is also odd. Okay, let us see the subscripts here 1 and 3. If every odd principal minor is what we say less or equal to 0, less or equal to 0. Okay, and the even principal minor, here it is 2, which is greater than 0. If we would have 4 by 4 matrix, then if we have H4 and if it came out to be greater or equal to 0, we would say that the given matrix is negative semi-definite. Okay, and negative semi-definite satisfies the condition for concavity of the given function. Okay, I hope I make myself clear in this video. Thank you.